Hello everyone, my name is Jacqueline. In this video, I will demonstrate the Linux deployment created for Promised Land's new secondary data center located in Independence, Missouri. This system supports 38 employees across multiple IT departments, including operations, applications, infrastructure, and CR teams. The goal of this deployment is to demonstrate Linux system administration, including server setup, user and group management, shared storage, security configuration, firewall protection, and scheduled system maintenance. In this demonstration, I will show the Linux server was deployed using AWS and how it supports the organizational structure of Promised Land's IC teams. So this is the name of my server, Ubuntu server, and as you can see, it shows running. Okay, and then it's also on the Linux platform. The instance acts as a secondary data center server and will host storage and administrative services for the organization. Now, I'll connect to the Linux server using SSH to begin demonstrating the system configuration. Okay, I'm logged in. To confirm that I am logged into the Linux server, I'm going to use this command, the hostname, who am I, in the uptime. The hostname identifies the server, and this terminal session allows you to perform administrative tasks and system configuration. Let's run this. Okay, so it shows I'm user 1, Ubuntu, and then you can see the uptime details there. Next, I'll update the system repositories and upgrade installed packages. This step ensures that the server is running the latest software versions and security patches, which is critical for maintaining a secure and stable environment. I'm going to use the code sudo apt update and the sudo apt full upgrade -y, and you can tell it's running. It's done. The apt update command retrieves the latest package information, and the apt upgrade installs any available updates. Next, I will install a command line package using the Linux package manager. For this demonstration, I will install HTOP, which is a process monitoring tool used to view system performance and running processes. That's the code sudo apt install HTOP -y. Enter. Okay, so it's already installed. Now that the package has been successfully installed, I will launch the program to verify the installation was successful using the htop command. Yes, and then this is how it looks like when the htop is successfully installed. In this step, I will demonstrate the storage allocation and disk configuration on the Linux system. The lsblk command shows all available storage devices partitions attached to the server, and so that is the command I'm going to use. So it shows the mount point, the size, how it is partitioned. Now I'm using the df-h command, which displays the mounted file systems and their usage in a human readable format. This allows administrators to monitor available disk space and ensure proper storage allocation. So this is the information we derived out of this code. Now I will create a mount point that can be used for additional storage. This directory will be used to store shared or expandable data in the future, and I'm going to use the command sudo make directory /mount/data, and that has been created. Next, I'll configure users and groups based on the Promised Land IT organizational structure. The company has several departments, including operations, service desk, application development, infrastructure, and CRM. To properly manage access to shared resources, Linux groups will be created to present each department. I'm using this command to create these groups. These groups correspond to the major teams within the IT department. Group-based permissions allow department to collaborate while restricting access to sensitive information. That has been run successfully. These users represent members from different departments within the organization. For example, Bill represents the operations team, Anita represents the service desk, Sajib represents the application team, Kovac represents the infrastructure team, and Cole represents the CRM team. Carrie represents the CIO who oversees all departments. So we are going to run this code. Alright. Now with this code, each user will be assigned to the group that corresponds with their department. This structure ensures that employees only have access to the resources required for their role. So we are using the code sudo user mode -ag for service desk for Anitra, same code, and then application for Sajib, and so on and so forth. Now let's run the command. Okay, that has also been run successfully. Using the groups command, we can verify that users are properly assigned to their departmental groups. Let's run this. Yeah, you can see Bill is in operations and Cole is in the CRM group. Next, I will configure shared file storage for the organization. Each department will have its own directory where team members can collaborate and store shared files. These directories will be located under the SRV/company, which is commonly used on Linux system for shared service data. Now I'm going to use this code to create them. I'll use this code to create the main company directory, which will store all departmental shared folders. And also with this code, I will create individual folders for each department, including operations, service desk, application development, infrastructure, and the CRM team. Okay, so let me run this. That's also been run successfully. Using the ls command, we can verify that the department directories have been created successfully because it's going to list them. And this is the application, CRM, infrastructure, operations, and service desk. Now I'm going to assign each directory to the corresponding department group. This ensures that only members of the department can access the shared files. Okay, let me run this. Okay, that has also been run successfully. With this command, the sudo chmod 2770 /SRV company /*. The permissions are set so that the directory owner and group members have full access, while other users have no access. The two at the beginning activate the set gate bit, which ensures that files created inside the directory inherit the same group ownership. So let me run this. That is done. So with this command, ls-l /SRV/company, with this code, we can confirm that the directories are properly assigned to their department groups with the correct permissions. Let me run it. Yes, and you can see the permissions are here for applications. Okay. Next, I'll demonstrate access control lists to configure Carrie Shoemaker's access across all department folders. According to the organizational chart, Carrie is the CIO who oversees operations, applications, infrastructure, and CRM. She needs visibility into every department to perform her oversight role, but we don't want to give her full group membership that would allow writing to team files. ACLs provide the perfect solution, granular permissions beyond the standard Linux user group order model. First, I will install the ACL package, which allows advanced permission management on Linux system. Now I will use the set facl command. I will grant Carrie full read, write, and execution permissions to each department directory. This will allow the CIO to access all company resources while attempting proper department level security. Using the get FSA command, we can verify that carry has explicit access permissions to the directory. And as you can see, carry here, user. Read, write, and execute. With the next command, the ls-l srv company, it will show the directory still maintain group ownership, but ACL allows additional controlled access where necessary. Okay. Exactly. Next, I will configure a firewall to help protect the server from unauthorized network access. Firewalls are important security measures that control which network traffic is allowed to reach the system. With the sudo apt install ufw-y, I'm installing the UFW, which stands for the Uncomplicated Firewall. It provides a simple way to manage firewall rules on Linux system. Before enabling the firewall, I'm allowing SSH traffic to administrators can continue to access the server remotely. That is the sudo UFW allow SSH. Okay. Now the firewall is being enabled, which activates the configured security rules. Firewall is active and enabled on the system startup. Using the UFW status command, we can verify that the firewall is active and SSH is allowed. So let's see. Okay, so status active, allow TCP. This command, sudo UFW status verbose, provides more detailed information about the firewall configuration. Okay. Alright. So this is the information that we derived after using that command. Now I'm going to configure a message of the day, also called MOTD. This message appears whenever user logs in the system and provides a security notice indicating that the server is restricted to authorized users. Authorized access on the promised land data center. Get code right here, cat/etc will show that message has successfully been configured. Next, I will configure a scheduled maintenance task using cron. This cron job schedules the system to automatically reboot every 2 years to ensure long-term stability and maintenance. Let me run this. Okay. Next, I'll use the sudo cron tab-l to schedule the reboot task. It's now successfully configured. Enter. So it shows that the reboot tab is successfully configured. Now I'm going to use the lsblk and df-h. I'll combine both commands. Finally, I'll verify the system storage configuration. The lsblk command displays available storage devices, and the df-h shows the mounted file systems and their disk usage. Okay. So now we have all the information here, size, mount point, and everything. I'm going back to use the ls-ld/srv command. Here it will show that the departmental directories that support the organization's file sharing structure. Let me run this. Okay, everything is perfect. I would also want to verify using the df-h-sudo uw status, verifying the storage system and the firewall status to confirm the server is properly configured and protected. One last time. Okay, this is fine. So to wrap this video, this Linux deployment demonstrates the configuration of a secure server environment for the Promised Land Secondary Data Center. The system includes user and group management based on the company's organizational structure, shared departmental storage, secure file permissions, firewall protection, access control list, leadership access, schedule system maintenance using the cron job, and monitoring tools installed through the package manager. These configurations demonstrate practical Linux administration skills and provide a secure environment that supports the organization's IT's operation. Thank you so much for watching my video.